We are going to look at quadratic inequalities. Graphing a quadratic inequality like y is greater than x squared plus 4x minus 5 is a lot like graphing a linear inequality. Number one, describe how you would know whether to make it a dashed, a dotted, or solid parabola. Well, look at the sign. If there's an equal sign, the answer can be on the parabola, and if there's not an equal sign, it cannot be on the parabola. It's either greater than or less than, so it would be dashed. So this will be greater than or less than with no equal sign is dashed. And if there's an equal sign, greater than or equal to, less than or equal to, then it will be solid. Describe how you know whether to shade inside or outside the parabola. Well, if you remember when we did quadratic inequalities in one dimension on the line, we picked a point, we tested, and we shaded. Actually, we did 2 dimensions on a coordinate grid. But again, we pick a point, test, and shade, and that's what we'll do today. So pick a point, test, and shade. If it's true, you shade where the point is that you picked, and if it's not true, you would shade the other side or sides. And we'll take a look at that today. All right, let's graph this parabola x squared plus 4x minus 5. If we have technology, we can use that to help us graph. So I'm going to just open a new graph page. Okay, so let's add a graph. Let's type this in. X squared plus 4x minus 5. So we have this parabola right here. We can move the window. We can see the vertex looks like it's 1, 2, 2 over, 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's 2 over. 2 over 9 down. So let's graph that 2 over 9 down. 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So here is our vertex, and if we want to check the zeros of the graph, it looks like the zeros are 1, 1, 2, 3, 4, 5, 1 and negative 5. 1, 2, 3, 4. All right, this will be a dashed line. So I'll draw our dashed parabola. That looks terrible. Let's try it one more time. Still doesn't look that great, but here it is. We could have done that. We could have found the zeros by quadratic formula. We could have found the vertex by the negative b over 2a like we did last unit, but since we have the graphing calculator, it's a little bit easier to use there. We're going to pick a point, test, and shade. So 0, 0 is an easy point to test. Let's test it. Is 0 bigger? This would turn into 0. This would be 0. Is 0 bigger than negative 5? Yes, it is. So here we would shade inside the parabola. Okay, let's try the next one. Graph y is less than or equal to, so it's a solid line, 2 times x minus 3 squared plus 4. Well, this one's easy to see the vertex. The vertex would be 3, 4. 1, 2, 3, 1, 2, 3, 4. You know, I'll be facing up. We could get a few of the points here using our table. Let's delete this graph. And let's type in a new one. So it would be 2 parentheses x minus 3 squared, 2x minus 3 squared plus 4. Okay, let's shift our graph. Okay, to see a few of the points, we can hit Control-T. To look at our table, we know the vertex is 3, 4. Then we have 2, 6, and 4, 6. 1, 2, 1, 2, 3, 4, 5, 6. We can sketch that. Solid line. Pick a point, test, and shade. Again, 0, 0 is pretty easy to test. Is 0 less than or equal to 2 times 0 minus 3 squared plus 4? Is 0 less than or equal to 2 times negative 3 squared is 9 plus 4? Is 0 less than or equal to 18 plus 4? Which it is. So 18 plus 4 would be 22. So we would shade outside the graph. And there's an example of one that's a solid line where you shade outside the graph. So there's graphing inequalities. The next page, solve the inequality. Okay, and then graph it on a solution. Okay, so this one's different because we have a 9 here, and if you remember back to the quadratics unit, in order to solve a quadratic using, for example, quadratic formula, we would get 0 on one side. So 6 says before we try to solve this graphically, let's first take a look at the graph. In your graphing calculator, type in these two functions. Okay, so let's do that. Let me hit Control-T to get rid of the table. Let's get rid of this parabola. I'm just clicking on it and hitting delete. And if we go to tab, we'll type in x squared plus 4x plus 4. So there's the parabola. And then let's type in tab and just y equals 9. And we can see what that looks like. So keep that in mind. Where is it? Sketch and graph the intersection points. So here the vertex is 1, 2, 0. 2, 0, and then y equals 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 9, and it was a solid line. Let me use my line tool. Okay, so here's this line. And where were the intersection points? Let's go back here. And it looks like the intersection points were at 1 and 1 and 5. Okay, so 1, and then 1, 2, 1, 2, 3, 4, 5. Okay, so there it is. They were at 1 and 5. Oops, again, that's a terrible parabola. And we should have a dash line, actually. And let's do this. Okay, so there's my parabola with a dash line. So we have sketched that graph. Oops, did I undo everything? Okay, there it is. Okay, so we have sketched that. But now it's saying, all right, how does this relate to finding critical numbers? First of all, what are critical numbers? Critical numbers are the x-intercepts, the zeros, just like we did last chapter. The critical numbers are the x-intercepts, the roots, the zeros of the graph. Find the critical numbers of this right here. Well, to find the zeros, you need 0 on one side, so we'll subtract 9 from each side. X squared plus 4x, this will be minus 5, and let's just set that equal to 0 to solve. You could use quadratic formula, x equals opposite b, or you could factor this, and this is pretty easy to factor using a box and circle. What multiplies to negative 5x squared, that adds to 4x, and that would be x plus 5. X minus 1 equals 0. And if we use zero product property to solve, what makes x plus 5 0? X equals negative 5. What makes x minus 1 0? X equals 1. How to use the critical numbers to find the solution? Well, if we take a look back at this right here, here was the negative 5, here was the 1. So the critical numbers are where your parabola meets the line. So to find the solution, what you can do is you can plug in and you can solve. Well, actually, we just use it to find the points where it crosses. So here, one of the points where it crosses was negative 5, 9, and one of the points where it crosses was 1, 9. So we can use it to find the solution. They are the x values, I should say. They are the x values of the solution. And the y values are just where it crossed. So here the y value is 9, and the x value is negative 5 and 1. Okay, so now here's where it becomes one-dimensional. Graph the solution on a number line. Ask yourself, should you make the critical numbers open circles or closed circles? So let's put our number line here, and let's get our negative 5, negative 4, negative 3, negative 2, negative 1, 0, and here's 1. All right, so this one right here, if it's open or closed, look at this, is less than. There's no equal sign, so those circles should be open because our answer is either going to be outside the circles or inside the circles. So to test if it's outside or inside the circles, pick one of these points and plug it into your quadratic x squared plus 4x plus 4 and check, is that less than 9? So let's check just an easy number. Again, 0 is pretty easy. That would make this 0, 0 squared plus 4 times 0 is 4 less than 9? Yes, that's true. So you would shade between the numbers right here. So what that means is we would shade between. How does the number line above relate to what we saw in the graphing calculator? Well, the number line is right here. So this is telling me you would shade in here. Actually, shade in here. Okay, so this is what we're going to practice today, this number line idea. So actually we're going to go really to one-dimensional. And if we look at the assignment, it's just graphing the inequalities with your graphing calculator and then trying this idea on the number line where you get 0 on one side, find the zeros, and then pick a point, test, and shade on the number line. So that's the majority of the assignment today. But let's look at one application problem. A rectangular parking lot with a perimeter of 440 is to have an area of at least 8,000 square feet. Within what bounds should the length of the rectangle be? Let's start with the picture. So if you don't have an idea of where to start, picture is always a great idea. So there it is. The perimeter is 440, and we know that we have a width and a length. So the perimeter is when you add 2 of the widths plus 2 of the lengths. So 2 times W plus 2L equals 440. And the area, length times width, is at least 8,000. So here are 2 equations here. And since we have 2 equations and 2 variables, let's use a substitution so that we can get rid of one of the variables and write an inequality. So let's solve one of these for W or for L. So I'll pick the first one. Let's solve this just, how about for W? So we have, this is my arrow right here, 2W plus 2L equals 440. Goal, solve for W so we can plug in. So minus 2L from each side. Whoops. 2L. 2W equals 440 minus 2L. Get rid of the 2. Okay, so we have 440 minus 2L equals, oh, I forgot to divide each by 2. So W equals half of 440 is 220. Half of 2L is just L. So we're going to plug this in, use substitution, plug it into this function right here, and we will solve. So we have L times 220 minus L equals 8,000. Okay, we will distribute, and look, we'll get a quadratic. Oh, and I did this wrong. I put an equal sign here, but it says is to have an area of at least 8,000 feet. So I should change this inequality. The area needs to be greater than or equal to. So that's this right here, greater than or equal to. So I would move this down, and let's write, so again, we would have 220L minus L squared is greater than or equal to 8,000. Okay, let's solve this quadratic. Let's get everything on one side. So we have 0 on one side. So I'm just going to subtract 8,000 from each side. Well, let's put it in a standard form as well. So you have L squared, negative L squared plus 22L minus 8,000 is greater than or equal to 0. Now it's a quadratic. And we're going to find what values it's between, so we're going to use that number line idea, but first we have to solve for L. So let's use quadratic formula. I don't want to try to factor this. So A equals -1, B equals 22, C equals -800. Plug into quadratic formula, X equals opposite B, plus or minus the square root of B squared minus 4AC all over 2A. X equals -22 plus or minus the square root of 16,400 all over -2. And if we solve each one of those, so do the plus and the minus, X equals 45.7 if we round, about 9.7, so wavy lines, and x is about 174.03. So it says, within what bounds should the length of the rectangle be? It's going to be between these. And to be sure, I can pick a point and test and shade. So if this was my number line right here, this would be 45.97. This would be 174.03. It would be a solid dot. And I would pick a point like maybe 50. 50 is between those. And I would test it in this right here. And if it works, I would shade between. And 50 would work if I shaded it. So there's our number line. Okay. So for your assignment, you have a few types of problems. Number one, can you graph the inequality? Use the graphing calculator. Number two, it's a problem like this where you solve the quadratic and then you graph it on a number line, pick a point, test, and shade. And number three, same thing, except in word problem form where you have the number line, pick a point, test, and shade.